In this video, we're going to talk about the interquartile range and also outliers. So, the range, standard deviation, and variance are not resistant, which means they are affected by outliers. Quartiles, however, are resistant. So, because the quartiles are resistant, sometimes we like to use the interquartile range. Which we abbreviate IQR to use as a measure of dispersion. So the IQR is the range of the middle 50% of the observations. And we'll see what that means graphically in a minute. So the way we find the IQR is by subtracting Q3 minus Q1. So the more spread a set of data has, the larger the interquartile range will be. So for example, let's find the IQR from the quartiles we found in the example at the end of the last video. So Q3 is 4,668 and Q1 is 1,185. So we have the IQR is Q3 minus Q1, which is 4,668 minus 1,185. So if we do that, 4,668 minus 1,185, we have 3,483. So what does that mean? Well, let's draw a picture. So remember, Q2 is in the middle, which is the same as the median. And we have Q3 and Q1. So the interquartile range, when we say the middle 50%, it is this distance here. And we know that's 50% because the quartiles divide everything into 25%. And we're going across two quartiles, so we add that 25 to 25 and we get 50%. So what does the IQR actually mean here? It means that the range of the middle 50% of the data is $3,483 because that's what we were measuring. So that's how you find the interquartile range. And why the interquartile range is important is because we need it to be able to check for outliers. So to do that, we need to find the cutoff points, which we call fences. And the fences serve as the boundary between typical and extreme data values, which those are also called outliers. So to find the lower fence, we take the first quartile and subtract 1.5 times the interquartile range. To find the upper fence, we take the third quartile and add 1.5 times the interquartile range. So for example, let's find the upper and lower fences for this example we've been working on. So we know that the lower fence is Q1 plus 1.5 times the interquartile range. So Q1 was 1,185, and we're going to subtract 1.5 times, remember our interquartile range was 3,483. And that gives us a lower fence of, well, let's see here, 1185 minus 1.5 times 3,483. So we can type that all in at once. And we get negative 4,039.5. So that's negative $4,039.50. Okay, what about the upper fence? Well, the upper fence here is we take the third quartile and add 1.5 times the interquartile range. So the third quartile was 4,668. And now we're going to add 1.5 times the interquartile range. And if we do that, we get 4,668 plus 1.5 times 3,483. And that is $9,892.50. So, if we have any outliers, then they either have to be less than negative $4,039.50 or greater than $9,892.50. So let's go back to our data. So there's no negative number, so nothing is too small. But do we have something that's bigger than $9,000? Well, yes, we have this $21,147. So our outlier is the $21,147. So remember, outliers are either less than the lower fence or they're greater than the upper fence. And that is the end of section 3.4. In the next section, we will talk about the 5-number summary and box plots.